Hello, I'm Gary Gray from Wiring Training. Today's video is all about contactors. I've got quite an array here, as you can see, and by the end of the video you'll have a good understanding how contactors work, how to wire them, how to replace a coil in a contactor, why we use thermal overload relays and how they actually operate, the addition of modules like this timing module and this module, which is an add-on for adding extra contacts, normally open, normally closed contacts. Now I'll show you something today that probably many of you have never come across before in a particular contactor. But first we'll get into the nitty-gritties and show you how they actually work. And I've got a great example here of a really early model contactor, which will be a great example. I've rounded up this collection of contactors just to give you an idea of the different look and shapes that some of them have. Now, the reason why we want to use a contactor, we could use a relay in a lot of cases similar to this one here. That's just a small compact version, standard sort of a relay. Now that's got a rating of 12 amps on that set of contacts, so that's often not enough. If you grab a contactor and have a look at the ratings on this one, we can see here that it'll tolerate a lot higher voltage than what this will. This usually only goes up to about 240 volts for a relay, but on this contactor, this one's good for 690 volts AC. And the amperage, it can actually get up to 32 amps through the set of contacts. Now, another thing you should be very aware of with this, the contacts, normally we have 3 sets in line. That's designed for motor control for a 3-phase motor, but they're used for a lot of other purposes as well, which I'll explain shortly. But on this right hand side, we've got another set of contacts, and that one has a different rating to what the main 3 contacts down here have. If we look over on the side, we'll have a look here, auxiliary contact. Now this one is rated at 25 amps instead of the main ones are 32. And that's the best scenario we're going to get out of that, depending on what voltage we're running, as to what amperage we can actually get out of that. So that you need to be mindful of that. And the other thing is, you don't assume that all these contacts are going to be normally open, and when it's energized that they close, because some contactors will have different arrangements. And this auxiliary one on this one, you can see it's got a little NC there. I don't know whether I can get it close enough to zoom in. That means it's normally closed. So at the moment there's a circuit through there, and when it energizes, it actually opens that one. Now if I grab another one, we'll find one here that's normally open. If you look at this one here, we can see here it's got NO. So this set of contacts is exactly the same as all these other 3, that they're all normally open until the contactor is energized, and then they all close. So just be very aware of that when you're wiring something up. Now, why would we use a contactor? Well, if we swing around a little bit, if we have a look here, I've got a few different controls. Now we've got this unit here, which is a temperature controller, and it's got for heating and cooling. It's often used on cool rooms, freezer rooms, air conditioning units, that type of thing. And that if we want to control a larger motor, this is not capable of doing that. The contacts inside here are not going to be able to switch sufficient load. We have a look here for heating and cooling. Both sets of contacts are rated at 10 amps at 220 volts. So if you want to run a three-phase motor or higher amperage load, you would need to do it through a contactor. Now, another reason we might use a contactor is for lighting control at schools, big buildings, or other spots here. We've got an analog time clock. This one here is a smart clock, so we can schedule that using an app on our phone just by pairing it, and that can come along and control a contactor like this, and we can have that contactor switching this coil, or that time clock switching this coil, which we can have 4 sets of lighting circuits. So we can switch quite a lot of lighting load with quite a large amperage by feeding it through a contactor. So that's another good use for it. Another thing we might use a contactor for is having PLC controlling motors, pumps, quite elaborate type of circuitry, and the outputs, we can feed them to contactors and switch large three-phase motors on and off with this little unit here. So that's basically why you might want to use one. And now we'll go through a few different types. Now I've got a very old unit here, which is quite ancient, but it's quite handy to show some of the workings of it. This actually is to control the amperage of it going to trip, and basically what happens is the current of the motor or the load goes through this coil and creates an electromagnet out of it, and it operates this pin. Once it's energized to its tripping point, it operates that lever, which pops up, and this little spring-loaded unit comes out and opens up contacts in behind there. It's a bit difficult to see, but that's a very early one, and I'll come back to that one in a minute, because that is an amazing, unique type of contactor, that one, which you probably have not come across before. Now we've got just a few others here, different brands. So they have different style of overload on each one of these. These are called a DOL, direct online starter. So they're used predominantly to start electric motors. And a direct online just means that there's no current reducing system in place. They just, as soon as you hit the start button, bang, they're at full load going straight to the motor for starting. So they do pull a lot of current while the motor's getting up to speed. Now with this one here, this is the overload, thermal overload. That's the contactor in the upper part. And this is just our switch for starting and stopping via the push buttons on the face of the unit. They push on that set of metal contacts inside. Just press that down, and then we've got the coil sitting at the back, and I'll change over a coil to show you the process on one of the brands of contactor shortly. But just to adjust the current on this, you can see this one has actually got a slide to change the current, and that's the tripping current that you set. Now I've got a few other different ones here. Oh, thermal overload. This is an electronic one, and the beauty thing I like about the electronic ones is the range of current. We've got right down low 5.4 amps tripping just by turning this adjustment around, right up to 27 amps, which is a massive range of current. So I find those great. You can just carry one of those in your vehicle and it does most jobs that you're going to need it to do. But once you get into some of the others, there's not a huge range in these older style ones. This one goes from 12 amps to 16, so it's only a 4 amp range. Here's another one here. This one here is 3.7 to 12. It's got a reasonable amount of range on there. And you'll notice on this reset button, it's got a manual or a trip. We can set them up so they automatic reset after a cooling down period, or they may you can put them in manual, so you've got to manually reset it. Now there's a few little add-ons. Just before I go there, I better show you a couple other different contactors as well. This DIN mounted, a lot of them are DIN mounted. This is more what you would fit in a switchboard, because it's compact size. So if you wanted to switch a heavy load for some reason with a contactor in the switchboard beside circuit breakers, that would be a good choice. I think that one's rated at 25 amps. Yes, it is 25 amps, so quite a heavy load for a very compact unit. This is another style which may or may not be mounted on a switchboard, but definitely on a DIN rail, like this type of gear here. Clips on the back, spring loaded locking mechanism there for release. So a little bit different style to what some of the others look like. Now there's a few different add-ons as well that we've got. This is a timer. It's only a very short one here, 0.3 of a second up to 30 seconds. And that adds on the face of this contactor, clips on. And then when that contactor activates, the timer starts timing. And we've got a set of normally closed and normally open contacts either side that we can use for control circuitry. They get used on the likes of Star Delta starters, but a host of other things with machine control as well. So if you see in the back here and actually trigger what a contactor would do, it would pull that up. You should be able to actually hear the contacts close. So it's set for about half a second. When I reset it, pulled it out too far. There we go. Okay, so there's that type of timer. Now that we've got auxiliary contacts as well, which we can just lock on the front, similar to what I did with that timing unit. And this, if there's not enough contacts here, or they're not the type you need, you can buy add-on modules which introduce extra sets of contacts. In this case, it's one normally open and one normally closed set that gets added on. That locks in and operates with the contactor and has a release button in the top to remove it. Quite simple. So now we might go on to replacing a coil if it happens to burn out or it has the wrong voltage for what you want to use. But that's quite a simple process on some contactors and not quite so simple on others. Now in this particular one, it's a Sprecher and Shure brand, which NHP sell. There's a actual bit of clip in there that springs forward. We do the same to this side. We spring that forward with a screwdriver, and then the whole thing lifts off like so. And then we just lift that unit out, change it over. That's a 24 volt, and you can tell it's an AC 24 volt, not DC. Some will work on both, but this one says 50 hertz, so you know straight away that that's an AC coil. So we might be swapping it over for a 3-phase control circuit. It's 415 volt AC again. So we just put our spring back on top, gently get it to line up, go back in. We flick our little clip or bar back where it belongs, top and bottom, and then that's ready to go. Now I might point out just a little dilemma I had many years ago, early in my career. I had what was known as a motor control, a star delta motor control, and I wasn't that familiar with the operation. I was called to a machine that had failed, and when I opened up the box, there were 3 contactors like this. There was an overload hanging off one and a little timer on the other one. Now I got there and I was familiar with the basics of what a star delta starter should do. It starts off first one's called your line contactor, and the next one is a star contactor, which goes in to get the motor started. It reduces the current, and then it comes out, the delta contactor comes in, and the motor runs at full speed. What was happening, this contactor was going in, the machine wasn't running, so I'd push the start button, this line contactor would go in, but then the star one wasn't. And I thought, well, before I got my meter out and started testing what was wrong, I just thought, well, I wonder if it's just the coil. And I pushed that in manually, and the whole thing blew up in my face. I was very lucky that I didn't lose any sight or have serious burns with that. And what actually happened was this contactor had malfunctioned and it didn't quite release all the way out. And as soon as I pushed this one in, I shorted out all the 3 phases because this one hadn't released. The contacts were welded together and it was still connecting through the voltage to the other phases. And I pushed this in and this put a direct short. Any of you interested in star delta starters, I'll go right through how to wire them up, all the wiring circuitry that goes with them, as I also will do far more with direct online starters. But that's in my Beyond the Basics course. So if any of you are interested in that, you can subscribe to the channel, or else leave a note below and just let me know you're interested, and we can get that sorted for you. So it's going to cover a lot of extensive stuff to do with all my 46 years of learning throughout the different areas that I've worked in. This is another add-on of a different brand. This one here is an Allen Bradley contactor, and rather than clip on the front like the Sprecher and Shure did, this one locks on to the side, and when the contactor activates, it actually pulls this contact in. So that clips on, locks in place, does the same sort of job as the other one. Right, now what I'll do is show you this big old unit here. This is a bit of an antique, this one. So this contactor is got to be mounted vertically because it relies on gravity to operate. And I've unbolted the internals of this one so we can pull that out. Now up top here, this is a splash guard or splash barrier. And the purpose of that is when the contactor gets pulled in and releases, there's an arc occurs on the contacts. And that arc between each one, if it didn't have a barrier blocking it, could actually connect across and have catastrophic failure of once it starts arcing, the air becomes conductive and it just continues on. Now with the auxiliary contact here, this one is really easy to see. We can see here when I operate it that the auxiliary contact is normally open. When the contactor is energized, it becomes closed like these others. So they're all normally open contacts. And the coil in this one that activates the whole show is this big old unit here that pulls in, electromagnet. When it's energized, pulls in, lever pushes the contact, and away it goes. And as far as tripping, this is another reason I've got this. It's a great example to show you what's inside these thermal relays, overloads. Inside of this is a smaller version of this here. Now what that is, it's a little element, a heating element. When this switches, the contactor switches on, the load of the motor or whatever the load is, the current flows through this little coil, and once it gets high enough, it starts getting hot. It heats up this bimetal strip, and the bimetal strip starts curling and operating the reset. This is actually, it was in a trip state a moment ago. There's our little switching arrangement there that would hold the circuit that holds the coil in place until it's tripped. And once it's tripped by either one of these, in this case we're only monitoring two of the lines. So on all the modern ones we would have three. It would be monitoring all three lines together. This one's only doing two. So if this middle phase happened to be drawing a massive load, it's not going to detect it. So it's a bit of a downside of that arrangement. So that's that one. Now we'll move on. Before we do, I might just mention what the unique features. I'm going to do a bit of a demo there of what I've wired up as a start-stop station on a DOL motor control. Before we do this unit here, why I had this set aside is because it's so unique. I couldn't believe it when I first came across one, and my boss actually told me what it was that made this unit operate. We got called to a fault. The unit, the motor would try to start and it would instantly trip out every time before the motor got up and running. And my boss said, "Oh, we've got to put some oil in that." I said, "Oil? You're joking." Well, inside this is called a dash pot, and this is supposed to have oil in here, and it's quite dry, so this would not work well. Now it has very fine oil in there, so we screw that up, and that determines what current it's going to trip at, and the oil is a damper to slow down the operation of the electromagnet pulling up the little button that trips it. So quite unique. And yeah, I was blown away the first time I saw one of those, and I thought I'd keep that for future. Now if we move over to where I've got my test arrangement set up, we'll fire it up. Now this is a DOL setup, so we've already got the contactor and the overload in there, wired up to remote start-stop station and an Estop. So I've got a little 12-volt lamp there that's simulating the motor, and we'll power it up and just give you a rundown on its function. So a normal DOL for motor control has a start button here with a stop button, and in this particular case I've wired it up for remote start and stop as well. So we've got start and stop button there, and we've also got an E-stop, so that can be mounted on the machine to shut the show down as well. Now, one thing you need to do when you're wiring up a DOL contactor or a contactor with an overload is to confirm that you've got it right. There's an actual trip switch here. Now, once that's tripped, it won't start. It's got to be reset. So the only way we can reset it, and even if we try to start it with this button, it won't. It has to be reset by pressing the stop button, which pushes on that blue tab there. So now we know, when we've done that triggering, we know we've wired it up correctly, and it shuts the contactor down if it ever gets into an overload condition. So I'll reset it, and now of course all our buttons work normally again. But another thing that's missing on a lot of contactors is when we've got a three-phase load, is always using all three sets of contacts, so that's fine. When you're using a single phase load, 240 volt single, or whatever voltage it happens to be, there's many electricians that don't realize you have to run an extra wire around to make every line get the same amount of current flowing through them. Now again, that is covered in full detail in my Beyond the Basics training, so I won't go into that on this particular video. But anybody wanting to find out more information, make sure you leave some comments down below. Now, just before we close this session off, I should point out, as typical in a lot of cases, this is running dual voltages here. The control circuitry is running 24 volts, and the feed to my lamp is only 12 volts, which is coming off the power supply here. The 24 volts for the coil is AC, is coming off the other transformer up there. Now, often you would have 24 volt control circuit going through your start-stop stations, and you would have mains voltage going through the contactor to drive a motor or some machine. So yeah, quite common to have dual voltages present, so just be aware of that when you're working on them at any stage. And that other voltage can be whatever you happen to want to use. In my case, I'm using 12 volts getting switched through when I hit the start button. Okay,